G'day again. Today we're going to look at some applications of calculus which will help you do this question, which got an example, and a few of your HSE questions. So the basics of applications of calculus at 2 unit level are to do with displacement, velocity and acceleration. So displacement, they usually use the letter x for displacement, so how far things have moved. Velocity, sometimes they use the letter v, but more than likely they'll use x dot, so you could have v or x dot. Acceleration, they will use a, so they use a, or they also use x double dot. Now what this means is if you've got displacement and you want to get to velocity and then get to acceleration, you're differentiating. So in other words, you've got x, and velocity is some distance in terms of time. So you would differentiate this and get dx dt. So velocity is the change in displacement. So the change in x. Okay, so that's what dx to t, the change in x is the velocity. And acceleration is the change in velocity. So if you're going at a velocity and you suddenly change velocity, well, you're accelerating. Okay, so that's d squared x to t squared. Okay, so this is the change in v, or the change in velocity. Okay, and they're pretty much the basics. If you go in reverse and someone gives you the acceleration, then to go backwards, it's exactly the same as what you've learned with differentiation and integration. So if we're going backwards, so we're going from acceleration and we go upwards, so here's some acceleration equals, I don't know, minus 10. And it's going, it's falling downwards. Let's assume it's gravity. You could say minus, we'll make it accurate, how's that? Minus 9.8 metres per second squared. It's going downwards. If you want to find the velocity at some sort of time, well then you integrate this. So you would integrate that, so velocity would be that. So the velocity would equal minus 9.8 t plus c, and then you'd find the constant by giving some information in the question, which we've got one here, which we'll have a look at. And then to go up again to displacement, well, you're going to, so x is going to equal, integrate that to get your displacement. Okay, so if we integrate that, you'll get minus 9.8 t squared on 2 plus, I don't know, let's say c was known, it's cx plus another c, or k. We'll make it another constant. Okay, or something like that. So you need to learn those patterns of differentiate to go this way and integrate to go that way. Okay, and they're the two main patterns you need to be aware of. So let's have a look at this example, and this will be typical of a textbook type example, possibly an exam question. So let's have a go at it. Velocity of a particle is x dot equals 1 minus 2 cos t. Whenever you get cos and sine as velocity or acceleration or even displacement, you're looking at something, so if you look at, we'll just look at a cos curve. It doesn't matter whether you look at cos or sine. You're looking at something which changes and goes up and down. So like a pendulum. So if you have something, oops, that's not a very good pendulum, is it? A bent rope. So if you've got a pendulum and it's swinging, you know, between there and back again, so it's going out that way and then back, it's going like that to that, about some centre point, which is the same as a cos or sine curve. And that's typical of a lot of questions that you get which are swinging and they're changing through some central point out here. So when you're going out here, here at this point here is your greatest or is your greatest velocity, because you're travelling through, and then at this point you're starting to slow down because gravity is slowing you down. Out here is your greatest acceleration, even though it's at zero, it's accelerating this way at the highest level. So this is where your acceleration, you know, you're really, really accelerating here, and here is where you've got the most velocity at this point there, okay? So in terms of a pendulum, if you're ever working with these questions, your greatest acceleration is out here, or out here going that way. Your greatest velocity is always passing through the middle point. That's where you're the fastest, because after that point, going this way, you're slowing down, and going this way, you're slowing down. Okay, and they're really handy points to remember too. So we're looking at velocity of a particle of 1 minus 2 cos t. Okay, it says initially the particle is 2 metres to the right of the origin. That's another point to note. To the right of the origin means this is positive. So if you're working with displacement, which this is stating the displacement, you're saying that x to start with is plus 2. So to the right is positive. If it said I'm 2 metres to the left, this would be negative. You'd start off with a negative displacement, okay? So in this question, the displacement is positive. It starts off initially, whenever you see initially, that means when t equals 0. And we're going to have this is plus 2. So initially, x is equals positive 2, okay? So there's a velocity equation. Initially, they tell you some facts. Find the initial velocity. Initial means t, or the time, is 0, okay? So if we put 0 there, we can find the initial velocity. So it's pretty straightforward from that point of view. We'll just go x dot equals 1 minus 2 cos 0, okay? Because time is initial velocity, time is 0. So we'll put t equals 0. That's what that means. So you just put cos is 0 there. Well, we'll just look at our cos graph there. Well, what's cos 0? Well, cos 0 on a normal cos curve is 1. And this is 2 multiplied by cos 0, so that equals 1 minus 2 times 1. Well, 2 times 1 is 2, 1 minus 2 is minus 1. So the initial velocity, equals minus 1, and we're in metres. Oh, it doesn't say. Let's assume it's in metres. Minus 1 metres per second. Okay? Oh, it is in metres. So we've got metres there. It is in metres. Great. Okay, find the maximum velocity. Well, how do you find a maximum or minimum of any equation? You differentiate and put it equal to 0. So we've got this, we're going to differentiate it and put it equal to 0, just like you've done before. That's how you find the maximum. So we've done that one. Now we're finding the maximum. Okay, so we've got the velocity, so there's our velocity equation, so let's differentiate it. If we differentiate that, what do you get? Well, I just told you before, if you differentiate velocity, you end up with acceleration. So we're actually finding the acceleration. So we differentiate this, differentiate that, you get 0. Oh, sorry, over here, differentiate that, you get 0. Differentiate cos t, if we differentiate cos, you get minus sine. So this is minus cos, well, minus minus is a plus, so we're going to get plus 2 sine t. And we're differentiating with respect to t. Okay, so there's our acceleration, and we want the maximum, so we're going to put that equal to 0. So when does 2 sine t, we'll get rid of the plus so we don't get confused, 2 sine t, when does 2 sine t equal 0? Well, let's look at our sine graph. Well, it obviously equals when it's 0, so you can say, well, when t equals 0, it's 0. When else does it equal 0? Well, it's going to equal 0 there. Well, what's that value on the sine graph? Well, that's pi, so t could equal pi. Well, when else it's also 2 pi, isn't it? So 2 pi. And it will keep going. Now, ideally, a nice answer is to say 2 pi, 3 pi, etc. Okay, so you're saying whenever these times happen, well, that's when you're going to get a maximum velocity at this point, this point, this point, this point, this point. So you can put any of those back in to the velocity equation and you'll get the maximum velocity. So you can put 0 in, pi, 2 pi, 3 pi, okay? So let's put them in and see what happens. So here's our velocity. So x dot equals 1 minus 2 cos, put in 0. Well, what's 1 minus 2 cos 0? Well, we already figured that out. It's minus 1. Okay, let's put in pi. So x dot equals 1 minus 2 cos pi. Well, let's have a look up there. There's pi. There's 2 pi. If we put in cos pi, we're going to get minus 1. So this will equal minus 1. Here it's going to equal 1. Minus 2 times minus 1 is 2. So 1 plus 2 equals 3. Well, when else is it going to? Well, 2 pi. So let's put 2 pi in. So we're going to get x dot equals 1 minus 2 cos 2 pi. Well, let's go back up to cos. At 2 pi equals 1. So we're going to put a 1. And you're going to get the same answer here. So that's going to equal minus 1 meters per second. Now let's put in the next one, which is 3 pi. So you get 1 minus 2 cos 3 pi. Now you've already figured it out because you're aware at this level. 1 minus 1, 1 minus 1. I already explained that it's going like this. So this is going to equal 3 meters per second. So the maximum velocity in this case is 3 meters per second, and it doesn't matter which one of these you pick, that's the maximum velocity. So that's just showing you by doing it each step that you can see that it is oscillating like that, and it's changing as it goes, as it passes through that central point. Going this way it's 3, and coming backwards it's only minus 1. Okay, so the maximum velocity is 3. Find an expression for the displacement in terms of t. Well, how do you find the displacement if you've got the velocity? You go backwards. So we've differentiated to get acceleration. You're going to integrate. Okay, so I'm going to rub this section off here, and we'll put in 3, and we'll integrate. So we're going to integrate 1 minus 2 cos t dt, and this time I'm putting the dt in. Okay, find an expression. Well, let's just integrate that with respect to t. Raise that to a t, and we just get t. That's pretty obvious. So we're doing displacement, so it's just x, t. Integrate cos, and we get a sine. So this will be minus 2 sine t plus c. And you have to get rid of the plus c for it to be a completed equation. What do you know? Well, you know initially it's 2 meters to the right. So we have to put t as 0 and put this as 2. So 2 equals 0 minus 2 sine 0 plus c. Well, that's nothing. Sine 0. What's sine 0? Well, here's a sine curve. There's 0. It's 0. So this is nothing, nothing plus c. Well, guess what c is? C equals 2. So therefore, c equals 2. So your equation is going to be this. If we write it again, your equation is x equals t minus 2 sine t plus 2. And you're done.